Hello, this is Mr. Klingler, and today we're going to talk about vertical circles. Vertical circles are a lot like horizontal circles with one small difference. That, of course, is gravity. Any problem we attack, we're going to have to consider the effects of gravity. Now, when considering these effects, I think it's easiest to work with an example. So the example I'm going to work with is that of a Ferris wheel. So as I picture all of this, I'm going to discuss it in terms of a Ferris wheel. Let's start at the bottom. At the bottom, it should be fairly clear what's happening. Imagine yourself on a Ferris wheel. You're sitting in the seat. And at the bottom, you're going to start curving up as you travel. Okay, if that's the case, at the bottom, I should experience two forces. Clearly, I experience the force of weight, but in addition, I'm going to experience the normal force. Which of these two forces is bigger? Well, clearly, Fn has to be bigger than Fw because I need to go in a circle. Therefore, I need the net force to point towards the center of my circle. To write a sum of the forces equation, this would describe the forces acting while I'm at the bottom of the circle. Okay, the top is a little harder. The top is a little harder because there are three possibilities depending on the speed at which you travel. Let's look at all three. In a normal Ferris wheel, as you go around, you don't fall through the bottom. You must have a normal force upwards. So we'll call this moving slowly. The center of the circle is below us. Looking at this, it should make sense that the force of weight has to be greater than Fn to keep us in our circle. Writing a sum of the forces equation, alright, that kind of makes sense. Now, imagine the Ferris wheel breaks. It goes crazy and starts speeding up faster and faster and faster and faster. In fact, imagine it's going crazy fast. Well, if you were in a Ferris wheel and there was no cage around you, you would go flying off into the parking lot as soon as you reach the top. Ouch. Alright, let's instead say that you managed to stay in your seat. Well, what would be holding you in your seat? Either the seat belt or the bar above you. Clearly, your speed is so great that the force of weight is not enough to keep you in your circle. In fact, you need more force so that you can maintain your circular motion. In that case, Fn and Fw would be pointing towards the center. Writing a sum of the forces equation, notice, towards the center of the circle is positive, so I write both of them as positive. This is often the case, the going too fast scenario, when you think about a roller coaster going in a loop-de-loop. As it goes around the top, it's going so fast that it needs the track to keep it going in the circular motion. Alright, somewhere between fast and slow, there's a third possibility. What happens if, well here, the force of weight was too much, so normal had to help balance it out. Here, force of weight was not enough, so normal had to help it out. What happens if force of weight is just enough? So we'll call this scenario, if that's slow and that's fast, this is just right. In this case, the force of weight is is the only thing keeping you in the circle. Where would this happen? What would it feel like? Well, the normal force here is equal to 0. So you're just about to lose contact with your seat. You would feel, well, no contact with the seat is like no contact with the floor. You would feel weightless. You would be have normallessness here. Therefore, you would feel weightless as you went at just the right speed. You'd just be losing contact with the ground. This is often a big sort of boundary condition or point of interest in vertical circle problems. A problem will ask, when do we just lose contact? Or when does the person just feel weightless? All right, and what they're talking about is when the force of weight is acting and nothing else. It also means they're talking about when the normal force is equal to 0. In both those cases, this is what's going on. Only the force of weight is what's keeping you in a circle. Okay. Those are really the cases that you encounter in vertical circles. I hope this has been helpful. Thank you very much.